Hey, welcome back. Today we're going to continue our discussion with the calculus of polars. And we're going to take a look at some AP type questions, and that will hopefully get us really good at the stuff. Alright, so let's take a look at question number 1. They are telling us a curve is drawn in the XY plane, and it's described by the following polar equation. Oh man, I don't know what that looks like. For between 0 and pi. Question number 1. This is a tricky one. It says find the angle theta that corresponds to the point on the curve with a y-coordinate of 1.5. Now here's the problem. This is polar. This is rectangular. Rectangular. So we have to convert. So we're going to have to convert our polar to a rectangular coordinate system. So we know that y is equal to 1.5. We want to write this as a polar. Oops, can't spell polar today. As a polar. We can do that by our formula for converting. Y is equal to r sine theta equals 1.5. But that's not enough because we know what r is, so I'm going to substitute that in. So we know that r is equal to theta plus 2 sine theta, and I can just plug that in. Theta plus 2 sine theta times the sine of theta equals 1.5. Now, here's the thing. We don't know how to solve this by hand, so we are going to use our calculator. I'm just going to type this in as y1 and this as y2. And I'm just going to find the intersection. Alright, so let me go and grab my calculator. I am using TI Inspire, the CAS. If you have the CX, it works the same way. So let me see here, Doc B, let me clear up my memory. I'm going to go to the graph. I like to use the scratch pad. I'm going to type in the first function. Now, I am not going to change my calculator in here to polar mode. Polar mode is not as good. I'm going to use functions, so wherever there's theta, I use x. So it'll be x, whoops, I should use parentheses, x plus 2, make sure you're in radian mode, sine of x on the outside times sine of x. Sine x. I don't know what this looks like. Yeah, oh my gosh, that's pretty ugly. So next I'm going to find out, graph my 1.5. Go to tab, I type in the 1.5, I press enter, and notice I have lots and lots of intersections here. But they do tell us to restrict the domain. So I'm going to go ahead and do that. So I'm going to go to restrict the domain menu, edit my graph, zoom or my window, do my window settings. I'm going to let my x's go from 0 to pi, pi. Press enter now, and now I only have 2 intersection points, and I have to find them both. So I'm going to get rid of this label here. I don't like the labels, so press here, delete, get rid of that. Go to menu, analyze graph. I want to find the analyze graph, not trace, and I'm looking for the intersection. Press enter. Now, lower bound over here. If I scroll over here, I'm going to press enter. Look for the upper bound. I scroll over, and we get 0.768. So there's one of my answers. Theta equals 0.768. Get the other one. I'm going to escape this, and I'm going to do the intersection again. Now remember, if the AP says you can use a calculator, you use the calculator. Lower bound. There's my upper bound. And what does it give me? It's kind of hard to see there. It looks like 2.71. So I'm going to write that in. 2.71. And there are my 2 intersections. Very easy to do. Now the next question says, same problem, for what excuse me, for what values between 0 and pi is dr d theta positive? So they want me the derivative of r with theta. So what does this say about r, and what does this say about the curve? So let's see. First of all, they obviously want me to find the derivative, so I'm going to go and do that. Dr d theta would equal, If I take the derivative with respect to theta, we're going to get 1 plus 2 cosine theta. Be very careful. This is not dy dx, which we talked about the other day. This is dr d theta. This is looking for the rate of change of the radius as theta is increasing. Set this equal to 0 because this is my sine chart, so I'm looking for my critical numbers. 1 plus 2 cosine theta. So cosine of theta equals negative a half. Theta is equal to 2 pi over 3 and 4 pi over 3. 4 pi over 3 is out of my domain, so there's my only critical number. If you're thinking this sounded like a sine chart, you're exactly right. We're going to go from 0 to pi, r prime and r, how to affect it, and 2 pi over 3. So if I plug a value anywhere between 0 and 2 pi over 3, I'll pick pi over 2. If I pick pi over 2, I'm going to get 1 plus 2. Cosine pi over 2 is 0, so this is going to be positive, so it's increasing. If I pick something like, okay, between 2 pi over 3 and pi, I'll pick 5 pi over 6. It's hard to see. And you get 1 minus 2 this, and this becomes negative once you use your trig values. Because you're going to get 2, you're going to get 1 minus 2 root 3 over 2. And that's going to become negative right there. Or just 1 minus root 3. That's negative. So let's see here. Where is this positive? We are positive. So we can say dr d theta is positive on the domain 0 to 2 pi over 3. And that is because, we haven't seen this in a while, dr d theta is greater than 0. We have not seen our sine chart there in a long, long time. So the next question is, what does it say about r? Well, remember, r is the radius. Well, because our dr d theta is positive, we know that r is increasing. Therefore, what does it say about the curve? Well, if r is increasing and we always measure r from the pole, we are saying that the curve is moving from the pole. Is moving away from the pole. And the last one we're going to take a look at, C. Let's take a look at C. Find the value of theta on the interval 0 to pi that corresponds to the point on the curve with the greatest distance from the origin. Again, for me, this sounds like candidate's test. Oh my gosh. We're seeing it. We're seeing all of the hits again, right? We just saw the sine chart, and now we're first derivative test, and now we got candidate's test. So again, we have to get our critical numbers. We already did that up here, right? This was our critical numbers right here. We already have that, so we know theta equals 2 pi over 3. My endpoints for my candidate's test are theta equals 0 and pi. And I just plug it in. Here's theta and r. My endpoints, 0, pi, 2 pi over 3. So I'm plugging into my theta, my r, which is theta plus 2 sine theta. And if I plug 0 in, we're going to get 0 plus 0, so that's at 0. 2 pi over 3, 2 pi over 3 plus 2 sine of 2 pi over 3. And again, they say I can use a calculator, so you know what? I'm going to go ahead and do just that. Escape, just like I want to do from school half time. Go to my home screen. And I'm going to write this out. Now I got the cast, I'm going to use my fractions. 2 pi, not pib, 2 pi over 3. Sometimes the calculator is picky. You might have to put a times sign in between there. Plus 2 times sine, and again, 2 pi, 2 times pi over 3. I press enter, that gives me something really weird. Control, and I get 3.826. So 3.826. Pi is not so hard to work with. Pi plus the sine of pi is 0. So this is just 3.14. So where are we the greatest? Obviously here. So we can say that the maximum distance from the pole is going to be at the point, remember we're going to go r comma theta for polars, 3.826 2 pi over 3. And that gives us our maximum distance from the pole. All right, other things we should be able to do: find the slope at pi over 3. That's dy dx. Find all the values in 0 to pi where we have a relative maximum. And again, this is just our first derivative test. So, hope you guys enjoyed the video. I'll see you all later. Thank you. Bye-bye.